Hi friends, as always I'm super excited to see you here. If you're meeting for the first time, I'm Dr. Uma Shankar Pandey and this is the Dr. USP channel. I host videos on media, communication, statistics and research on this channel. To stay updated with the latest on this channel, I urge you to consider subscribing to the channel. The correlation is a very important statistical test to test linear relationship between two variables, whether a change in one variable causes a change in another variable. Let's find out how to do the correlation test in SPSS. The Pearson correlation coefficient is used to find out the relationship between two scale variables. So to calculate Pearson's correlation coefficient, we'll use a sample data set in the IBM SPSS package. So for that, we'll open data file. Just to show you here, it's located in Windows, and under Windows there's program files. After you click program files, you'll have to click onto IBM. Inside IBM, you'll have to click onto SPSS Statistics 25. And inside that 25, you'll have to click onto the samples folder, and into the samples folder you get into English. Once you click English, this is what you get. So for the first one, we use this advertisement data set. So this is the advertising data set from the SPSS sample folder. If we go to the variable view, we'll find that there are two variables. Both of them are scale variables. The first is advertising spend and the second is sales, detrended sales. So the hypothesis is that there is a correlation between the advertising spend and the sales. That higher the advertising spend, the higher will be the sales. So let's analyze this. Analyze, correlate, and from there bivariate, because we're using two variables. Both these variables are taken in. In the options, we can click on to means and standard deviations. We can exclude cases pairwise. We'll go for Pearson's correlation coefficient because both our variables are scale variables. We'll go for a two-tailed test of significance, and we'll tell SPSS to flag significant correlations. That's all we require. We click OK, and this is what we get. The mean advertising spend is 3.7197. So the unit is not given, probably it's in hundred thousands or millions. The sales is 10.5688, and the standard deviation is less compared to the mean, and there are 24 companies that we are talking about. The Pearson's correlation coefficient is 0.916, and the two stars here suggest that the correlation is significant at the 0.01 level, because we can see the p-value here as 0.000, so it's less than 0.01. So our hypothesis has been proved here. We can see this graphically as well, and for that we'll have to go to Graphs, Chart Builder. Inside there, we'll click onto Scatter Plot, and we want to see this one, the one where a line can be drawn. We take this, we take the advertising spend in the x-axis and the sales in the y-axis. So we can see here from the scatter plot that the high correlation is demonstrated by this line. Most of these points are very close to the line. So 0.9 is a very strong correlation. So the higher the advertising spend, the bigger are the sales. So this also proves one of the requirements for doing the correlation test, that there must be a linear relation between the two variables. Let's do another test. We'll go to the same sample folder, and here we take the bank loan. We open it. We can see there are 12 variables here. The age is a scale variable, education is an ordinal variable, etc. The income, the household income, is also a scale variable, and there is that credit card debt. So we hypothesize that the household income and the credit card debt are correlated. That means the higher the household income, the greater will be the credit card debt. Analyze, correlate, bivariate. We'll take household income, we'll take credit card debt. In options, we'll click means, exclude cases pairwise. We want to find out the Pearson's correlation coefficient, two-tailed, and we want SPSS to flag the significant correlations. Okay. So it is showing the 850 observations. The household income is in $46,000. The credit card debt is around $1,500. But there is a lot of variance because the standard deviation of credit card debt is more than the mean. And this is the correlation table. We can see here the correlation coefficient is 0.552. And it is significant at the 0.01 level because the significance value is 0.000 as we can see here. So this proves the hypothesis that there is a strong correlation between household income and the credit card debt. That means higher the household income, the greater is the credit card debt. Two things to remember here. Firstly, correlation does not mean causation. That will have to be proved through other means. Secondly, this R value is also an indicator of the effect size. It tells me how much of the independent variable is because of the dependent variable, or how much of the independent variable is explained by the dependent variable. And for that, we'll have to square this Pearson's correlation coefficient. So it is written as small r, and the effect size is through capital R, and for that we'll have to square it. So if we square 0.552, we'll get around 30%. So 30% of the variation in the credit card debt is because of the household income. And we can see that graphically also. Graph, chart builder. We'll again go for scatter plot. We want to see the line. Household income is the x-axis. Credit card debt is the y-axis. So as we can see here, the correlation is not very strong because there are many instances which are far away from the regression line. This proves that the correlation is not very strong. So if it is below 0.7, it's regarded as a moderate correlation. Thanks for staying along, friends. As always, it was a delight having you here. I'll be back with another video very soon. Till then, have a great time.